You've probably had a chance to read through this problem. The big equation we need is that C equals 100 divided by the volume. Because the concentration of this substance is found by taking the 100 grams and dividing it amongst all that volume that we have, right? 100 grams always stays in the container because of the filtration system. So it always stays 100 grams, but the volume can shrink. That's a variable. Part A asks us to calculate the rate of change for the concentration. They want us to calculate C prime. That's what we're supposed to calculate. So that's where calculus comes in. We've got to differentiate this equation with respect to time, because each variable depends on time. So look, I'm just rewriting it algebraically a little bit. This is the same thing as this. Because now if I differentiate both sides with respect to time, we see the derivative of C with respect to time is C prime, because we don't know what it is. We need implicit differentiation. And then using the implicit differentiation over here, this negative 100 v to the negative second, then because of implicit differentiation, there's that v prime because using the chain rule. Or in a neater way, like this. So the initial information they give us is that there's been 5 hours. The tank started with 600 liters. So the volume after 5 hours is actually going to be 40. 40 is what we're going to plug in for V. And that's because we're decreasing 4 liters per hour. So after 5 hours, we've decreased 20 liters. We started here, decreased 20 liters. Now we're at 40 liters. Then the rate of change is 4 liters per hour. That means V prime equals negative 4. We're going down by 4 liters per hour. So I'm spilling over into... Oh, I copied A twice. Sorry. This is the same thing. Okay. So plug all that information in. We got negative 4 for V prime, 40 for V squared. So that's 400 over, I don't know, what's that, 16,000? 1,600. So that's 1/4 when you simplify. Okay, so C prime is 1/4. That's how fast the concentration is changing. B, again, they want C prime. They want the rate at the instant when 20 liters are made. So they're saying the volume is 20, and the water is draining at 2.2 liters per hour at that instant. So that means the volume is changing at negative 2.2 liters per hour. So again, plug all that information into what we had for a formula. That's negative 100 times V prime divided by 20 squared. That's 220. We got 20 squared is 400. And if we simplify that, maybe I can see a fraction from the decimal. 0.55, that's 55 out of 100, which is when you divide the top and the bottom by 5, that's 11 out of 20. So that's our C prime there. So the plus 30 grams per hour changes everything. Instead of having 100 grams over volume, now it's a variable. Now it's 100 plus 30 grams per hour over volume. That's our new concentration. So that means we've got to go back to the drawing board and take a derivative all over again. So let me rewrite this so that it's easier to take the derivative so we can use the product rule. Right? I just rearranged algebraically, no calculus right now. So if we want the derivative with respect to time, the derivative of C with respect to time is unknown, so we'll keep that as C prime. The derivative of this needs the product rule. This derivative of this times volume to the negative first. So if we take a derivative of this with respect to time, this time we don't need implicit differentiation for this parentheses because h is time. The derivative of this with respect to our h variable, our time variable, is 30. So that's the derivative of the first function times the second function kept the same. Now we need the first function kept the same times the derivative of the second function. So the negative 1 comes down, gets reduced by 1, but then we need the chain rule with implicit differentiation. The derivative of volume is V prime. So that's our new C prime because of time being a variable, because of that change of plus 30 grams per hour. So if we clean that up a bit, like that's times the -1, so I'm going to put a minus out front. V prime in the numerator and then V squared in the denominator. So if we plug in all the information from part 2 again, we've got 30 over the volume is 20 liters at that instant in part B. So 20 goes in for volume. And then over here, we got 100 plus 30 H. We don't know what H is. We don't know how much time has passed, but we can figure that out because in part A, we started with 60 liters. In part B, we were down to 20 liters. That's a change of 40 liters, right? And if we're decreasing by 2.2 liters per hour, that represents how much time has gone by. Okay, so when we plug in a number for H, we're plugging in 40 over 2.2. And then V prime is negative 2.2 because we're decreasing by 2.2 liters per hour, just like in the last problem. And then V squared. Okay, so when we do this out, 30 over 20, that's 3 over 2. In here, if you distribute this negative 2.2, it's going to be negative 220. Yeah, negative 220 for this term. Distribute here, the 2.2 and the 2.2 cancel out. It gives you a minus 30 times 40 over 20 squared. So 30 times 40, 1,200. Then subtracting by adding another negative 220, so that's negative 1,420 in the numerator. So if we simplify even more, I mean, this is now minus a negative, so that's plus, I don't know, 1,420. Can at least divide the top and the bottom by 10. Divide the top and the bottom by 2. So 142 divided by 2 gives us 71 over 20. So I double checked. I keep getting the same thing. It's not the answer that WebAssign has. So go ahead and skip part B. I put in a request for WebAssign to check because sometimes they do have the wrong answer programmed. But sorry, part C. Go ahead and skip part C because I think the wrong answer is plugged in.